Hey guys, so today we are doing sound, alright? So one of the first things that you need to know about sound is that sound is a wave, okay? Sound is a wave. So what is a wave? A wave is a transfer of energy, so a transfer of energy without the transfer of matter. So what happens, right, is that you manage to pass energy from one point to the other point without moving anything at all, okay? So you stand where you are, you let out a shout, and then so what happens, right, is that when you let out a shout, you let out energy, then the energy get passed on to air right in front of your mouth. It pass on to a next layer. So something like that. All right. So this is me. All right. So I pass the energy to the air layer in front of me, which pass to the next layer, and then after that a few layers, and then after that it keep on passing until 3 meters away. Let's say I have my friend, okay, who hear me shout. Okay, so I did stay where I am. Each of the air layers, right, remain in their relative position. It's not like this one move over here. No. Okay. Each one, after transferring the energy, they still stay where they are. Okay. So this is characteristic of the behavior of a wave. When I pass the energy from me to the friend, okay, each of the things did not move horizontally in this case. Okay, so and that's why sound is a wave. Okay, let's compare this to, let's say, me throwing a basketball to a friend. So the basketball will carry the kinetic energy together with the basketball and go to the friend. So when my friend gets the kinetic energy, right, he also gets the basketball at the same time. So in this case, the passing of basketball is not a wave. Okay, so yeah. Next thing, um, wave is caused by a vibrating source. Okay, this anything that vibrates can make a sound. Okay, that's why a lot of the unwanted sound, um, the other name for unwanted sound is noise. Okay, a lot of the unwanted sound noise is caused by uncontrolled vibration. So if let's say that I have an engine running, okay, the engine will be vibrating because of the moving parts inside. It causes a sound, it causes a noise, right? I mean, I don't really want to hear the humming of an engine, especially if it's especially loud, right? Okay, so these vibrations will cause the air to vibrate, which will cause the next layer of air to vibrate, and then the sound gets carried over a distance. Okay, so yep. Next thing, sound wave is longitudinal wave. Okay, what do you mean by longitudinal wave? Okay, so let's go back to our example of me shouting at my friend. Okay, so me shouting at my friend. Okay, I shout, the air in front of me will vibrate. How it vibrates? Okay, first of all, where is the direction of wave? The direction of wave is, of course, from me to my friend. Okay, direction of wave. The particle, let's focus on, let's say, this particular layer of air, right? Okay, what this layer of air will do when transferring the energy, right? It will vibrate like that. Okay, it will go left and right. It will start moving left and right. The air layer will start moving left and right, but still stay in that position. Okay, and this will cause, let's say, the next layer, let's say the green layer, okay, to move left and right. Okay, until each layer will transfer the energy to the next layer until you reach my friend. Okay, this left and right motion of the air layer, the medium, is characteristic of longitudinal wave. Okay, longitudinal wave, this is what I mean by the particles in the medium, they vibrate parallel to the direction of the wave. As you can see, each one of them, this one vibrate like that. The direction is also in the same straight line. Okay, that's why we call it a longitudinal wave. You will need to spell this one correctly. Wrong spelling. If they say if somehow in the question they want you to spell the word longitudinal wave, right, and spell it wrong, you're not going to get a mark. Okay, so loudness and pitch. Okay, so what is a loud sound? What is a high pitch sound? Okay, they are actually caused by some characteristics within the sound wave itself. Okay, loudness is due to amplitude. Okay, so amplitude, right, is the highest point to the lowest point divided by 2. So highest point is here, lowest point is here. I take and I divide by 2. This becomes my amplitude. Okay, so which is something like highest point to the equilibrium position. But of course, not every time the graph so nice to you. Okay, you may get graphs that look like that. Okay, so you have two choices. One is to find the imaginary middle line. Okay, otherwise you can also do what I just said. Take the highest point, take the lowest point, and just divide by 2. So this will be the amplitude. Okay, so the higher the amplitude, the more energy the sound wave have, and therefore the sound wave will be louder. Okay, so loudness, amplitude. Second thing is the pitch. Okay, so you have a high pitch sound and a low pitch sound. So yeah, high pitch sound, right, is because the frequency is high. Okay, high pitch, high frequency. But from the graph, right, you cannot see frequency. You look at the axis of the graph, the axis is time. So what you can only read, right, is the period. So let's say here I see one full oscillation, and then the time is 0.02. So the period is 0.02 seconds. And then I need to convert 0.02 seconds to 50 hertz. Okay, and then I do the same for the second graph. I get the frequency to be 100 hertz. So we compare the frequency. The second graph has 100 hertz. The first graph only got 50. So the second sound has a higher frequency and a higher pitch. So higher frequency, higher pitch. Hey, next thing, you just need to memorize this one. 20 to 20,000. Some questions will just want you to recall this. Okay, our human ear can only detect 20 hertz to 20,000 hertz. If the pitch is too low or the pitch is too high, we cannot detect it.